All right, note 33, antidifferentiation by substitution. So here we go. Let's review the difference between an indefinite integral and a definite integral. So remember, if I have something like this, a to b of f prime of x dx, this is called a definite integral. And that's just evaluated by doing f of b minus f of a. Yay or nay? Okay. Now, if I have something like this, let me change the color. And I want you to notice, do I have limits on that integrand? No. So this is called an indefinite integral. So every time you have an indefinite integral, you got to put the plus c on the end. And I believe we've already covered that and we've gone over that in detail. Are we cool? Okay. So here we go, guys. Let's start. This is pretty straightforward. It says evaluate this indefinite integral. I have the integral of x squared minus sine x. So what's the antiderivative of x squared?
X cubed over 3.
X cubed over 3. Yeah, you can say 1/3 x cubed. I think someone was about to start saying that. What's the antiderivative of sine x? Positive or negative? So what's negative times a negative?
Positive.
And because I don't have any limits, I got to put a what? Plus c. You can always check by if I take the derivative of this, do I get that expression? The derivative of 1/3 x cubed is x squared. Yep. The derivative of cosine is negative sine x. Yep. And the derivative of constant is 0. So there it is. Cool or not cool? Cool. Here's a list of some formulas. I think you guys already know some of those. I will give you a table eventually, probably the next time we meet, tomorrow or Wednesday. And we'll put a whole bunch of formulas, some of the basic ones that you guys know. All right, don't worry, we're going to go slow. It says paying attention to the differentiable. So I have some function, x cubed plus 1, and they're telling me that u is equal to x squared. Find each of the following antiderivative in terms of x. Okay, so this one, letter A, everything's in terms of x already. So I'm just going to go integral of x cubed plus 1 dx. I haven't done anything crazy. Antiderivative of x cubed is plus, and because I don't have any limits, I write plus c for some constant c. Cool or not cool? All right, this one says f of u du. So yeah, that's it, because it wants it in terms of x. So this one, I'm going to rewrite it as integral. It says f of u, so f of u is just this. F of u is just u cubed plus 1. So that's what I'm going to write. U cubed plus 1 with a du on the outside. What's up? Oh, because, well, I will. I'm just not doing it yet because I'm going to take an antiderivative and then I'm going to use that. All right, so what's the antiderivative of u cubed? Perfect. Plus antiderivative of 1. Well, it's with respect to u. I'm integrating with respect to u. So u, and then I put plus c. Now, they don't want it in terms of u. They want it in terms of x. So I know that u equals what? So I'm going to write x squared to the 4th over 4 plus x squared plus c. So my final answer is x to the 8th. Yeah, an exponent raised to an exponent, you multiply them. Over 4 plus x squared plus c. Are we okay so far? Nothing crazy, right? Notice on this one, Gian, see how I have a dx there? So on this one, I am going to pay attention to that. So it says f of u. So let me write what f of u is. F of u is u cubed plus 1 dx. Now notice that they're different, right? So I'm going to come here to the side. I'm going to rewrite this. U cubed plus 1. What was u again? So that's what I'm going to substitute with. X squared to the 3rd power plus 1. So that gives me, what's 2 times 3? X to the 6th plus 1. So now that's what I'm going to integrate. So I'm going to come back. Integral of x to the 6th plus 1 dx. Is everyone okay so far? All right, what's antiderivative of x to the 6th? Plus, there it is. Anything crazy? Okay. All right. The whole point of U substitution is to make life easy for us. You don't have to use the letter U. It can be any letter, but U is what is used in universally in all textbooks. They just call it U sub. But literally, you don't have to call it U sub. You can call it whatever you want. All right, you guys ready? So when we start, and don't worry, when we do the activity, I'm going to tell you what to start. You got to look for something that will make life easier. Some of you are probably good enough that you don't even need U sub. You can already see it. Like you're like, okay, the derivative of something has to give me this. All right, so if you can see it, fine. You don't need to use U sub. But here's how you do it. I see a sine x, I see a cosine x. And I think, how are they related? Well, the derivative of cosine x is sine x. So, well, okay. So I'm going to say U has to equal cosine x. And then check it out. I'm taking the derivative of U with respect to x, du dx equals, and what's the derivative of cosine x? Negative sine x. And then usually I'm just going to go ahead and multiply both sides by dx. So usually we just say du equals negative sine x dx. Sometimes, or the majority of the times, I just skip this middle step and I just go right from u equals cosine x to du equals negative sine x dx. Cool or not cool? And remember, this is a product. I can rewrite it so you guys so it's easier for you guys to see. E to the cosine x, and I'm going to write it like this. Sine x dx. Have I confused anyone? There is no negative in here. Yeah, well, hey, relax. Okay. You guys ready? Yeah, that's on the side, on the separate. All right, Delta doesn't do it this way. I don't necessarily agree with Delta because sometimes they have U's and X's. I just like to have just one variable and that's it. So here's how I would do it. I see a negative sine x dx. So what I would do is I would force this to be a negative sine x dx. So I'm putting a negative there. If I put a negative there, what do I got to do to the outside to balance it? Put a negative. Does everyone see where I got those negatives? Okay, now look what I have. Negative on the outside, integral. Look what u is. U is cosine x. E to the u. And look, negative sine x dx is just what? Du. Does that look like a lot easier to do? Yeah. What's the antiderivative of e to the u? E to the u. Put the negative in the front. E to the u plus c. Do I want it in terms of u? No, we need to go back to our x. I mean, in real life, don't ever go back to your x's. You're just asking for trouble. But in this, we're going back to this variable x. So here we go. This is the same thing as negative e to the cosine x plus c. Cool or not cool? All right, here we go. So again, all substitution is to help you take antiderivatives of something that looks complicated. Yay or nay? All right, Lavelle, focus, miss, focus. All right, so look at this expression here. I have an x squared and I have a 5 plus 2x cubed. I got to think, how are they connected, x squared and 2x cubed? Yeah, like I have an x squared and I have a 2x cubed on the outside or in the inside of the square root. Like, how are they related? Well, how do I get one from the other? Like, because I'm trying to determine what is my letter U. Remember that I'm taking a derivative. If I take a derivative of a polynomial, don't I have 1 degree lower? Yeah, so that means that I better make my U equal to the 5 plus 2x cubed. Why? Because look, du equals 6x squared dx. And I know, Chav, you don't have a 6 in there. I'm going to force it to be a 6. Is everyone okay with how I got that? No? Okay. What happened, miss?
I'm a little confused on just how you get the U. Like, I wouldn't see that. It's like what do we? Repeat what you said. Yes,
I want to integrate this, but it looks complicated. I want it to be simpler. So I need to substitute something to make it simpler. So what do I choose U to be? So I'm like, oh, okay, well, let's see. Don't write this down because it's wrong. If I chose u to be x squared, well, then my du would be 2x dx. I don't have a linear component that I can substitute for 2x dx. But I do have, this is wrong. If I make my u equal to the inside expression, 5 plus 2x cubed, notice that when I take this derivative, du, I get 6x squared dx. I do have a squared component, an x squared component that I can substitute. I don't have it yet. I just have an x squared at the moment. But look, here we go. I'm going to rewrite this. So it's easier for you guys to follow. I'm going to write this as 5 plus 2x cubed inside of that. And I'm going to put x squared dx. Now I'm going to change my color. I need a 6x squared dx, not an x squared dx. So I'm going to put what inside of that x squared dx? Now, if I do that, I got to balance it. What do I put on the outside? Do I put a 6 or do I put a 1/6? A 1/6. Let me tell you why. I need it to cancel out and be a 1. I don't want to change it. Does that make sense, Espinosa? All right. What did I say? I don't want to change what? The whole expression. I want it to be, so if I put a 6 in there, I got to put a 1/6 on the outside to keep it balanced, just like in chemistry. Are we okay? All right, so here we go. I'm going to substitute. Here we go. I write my 1/6 integral. The 5 plus 2x squared is nothing but the variable u. So square root of u. And the 6x squared dx is nothing but du. There it is. I have something a lot simpler. Hopefully you have enough experience to be able to do that antiderivative. Here is how you should be thinking in your head. The square root of u is the same thing as u to the 1/2. And now you just use your power rule. So 1/6, and then I'm going to add 1 to that 1/2. So u to the 3/2, or u to the 3/2. Yeah. And then I'm going to divide by 3/2, which is the same thing as multiplying by plus c. Don't worry, we're almost done, guys. The 2 goes into 6 3 times. And when I multiply that, that's a 1/9. So here's what I have. I'm going to bring it back right here. Here's my final answer. 1/9, parenthesis, do I want it in terms of u? The question was all in terms of what letter? So I need to have it in terms of x. So 1/9, and then I'm going to write, what was my u? 5 plus 2x cubed, close it, and put it to the what power? To the 3/2, 3/2, plus c. Here is my answer. Did that make sense, guys? Okay. No? No. Look, we got more. We got more. We got more, miss. So don't worry.
I know.
Come after school. All right. Here we go. I'm going to go slow. I'm going to turn cotangent into cosine 7x over sine 7x. And I have a dx on the outside like that. I got to keep the argument the same. So 7x, 7x. Are we okay so far? Haven't done anything crazy, right? I got to figure out what can I do to make this simpler, because right now it's pretty complex. Not complex like imaginary, but complex as in complicated. So u equals, I'm going to figure out what u is. I can make u equal sine, or I can make u equal cosine. Which one do you think is better? Okay, let's see. Don't write this down because it's not the right one. If I make u equal to cosine 7x, look what happens. du equals -7 sine 7x dx. Do you guys see that? But now look, the sine 7x dx is in the bottom, and then the dx is in the top. That I cannot substitute for a du. Do you guys see that? So then obviously, this is how you learn. It's trial and error. So I'm going to erase this. So what do you think my u should have been? Sine of 7x. Now look, I'm going to go slow. If that's my sine, so here it is. Now maybe some of you are confused by this. I'm taking the derivative of u with respect to x. So maybe you're getting confused with that. I'm doing du dx equals the derivative of sine 7x. cosine 7x times 7. But usually we don't, like, I will remove that dx on the bottom, times dx. Usually we just go right to this. 7 cosine 7x dx, like that. Does that make sense, guys? Okay. Is anyone lost right now? That's another, we're good? Okay, check this out. I come back over here, and I see, well, I have a cosine 7x dx right here. Now, it's only missing a what? A 7. So I'm going to take my colored pencil. I'm going to put a 7 right there. If I put a 7 there, what do I put on the outside? A 1/7 to balance it out. You want to make sure that the expression stays the same. Cool or not cool? Cool. Now, here's what I have. I have 1/7 integral. That 7 cosine 7x with the dx is all just du. And the sine 7x is a u. Let me rewrite it simpler so maybe you guys will recognize what it is. 1/7 integral 1 over u du. Does that look familiar? It is. It is ln. Good job. 1/7 ln. If there are no limits, it's absolute value. I know I haven't been doing a good job of that, but if there are no limits, it's absolute value. Chop. Why? Because the domain of ln is all positive numbers, x greater than 0, if it's an x. But what if the limits are negative? So that's why we put absolute value, so we can capture all of it except 0, because 0 is undefined for ln anyways. Plus c. Are we still okay? Yes. All right. One last step. Don't worry, this is the last one. I don't want it in terms of u. This integration was in terms of x. So what do I do? Plug in back what the u is. So this expression is nothing more than plus c. Does that make sense? Yes. Get that off.
So, like, I have a question.
Yeah, please.
So, like, in all of these, our u has been, like, in the expression. Is that gonna always happen?
No, it's not gonna always happen.
Okay.
Because I can think of one right now that it didn't happen, but we're not advanced yet. We'll get to those later on where there is one. Remember, we said this will take care of 95%. Just for AB, there's still integration by parts, partial fractions, but for AB, for what we are concerned, it'll cover 95% of.
So it'll pretty much be always in the integral?
For like inside of something or whatever. For now, yes, but there is a special case. We'll get to it, which we are going to get to it because that's one of the cases we have to get to. All right. All right, here we go. We're going to go slow. I see a dx over cosine squared 2x. Yeah, here's what we're going to do.
So would it be like 1 over cosine squared 2x?
1 over cosine squared 2x. Yeah, it's the same, with a dx on the side. 1 over cosine x is the same thing as secant. Yes or no? So rewrite this into something that we know. Secant squared of 2x with a dx on the side. Now, some of you probably do not need u sub, because what's the derivative of what gives you secant squared? Tan. So some of you can probably already figure this out, like, oh, there's going to be a half on the outside, blah, 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 whatever. If you don't need u substitution, you don't need it. But look, here it is. I'm going to go ahead and do it. I don't have secant squared of x. I have secant squared of 2x. So my u in this case is going to be 2x. You don't. I know some of you can probably do this in your sleep. The u is 2x. Look what your du is. Du is 2dx. Do I have a 2dx in there? No. You have a 2x, but that's part of the argument. That's not, I don't have a 2dx. So I put a 2 in the air, and then what do I put on the outside? A 1/2 to balance it out. And now look what I have. A 1/2 integral secant squared of u du. Now it becomes simple. What's the antiderivative of secant squared of u? You guys just told me a little while ago. Tan of u, and then I put a plus what? But I don't want it in terms of u, I want it in terms of, so I'm going to write 1/2 tan of what? 2x, that's what u was, plus c. And I know some of you probably didn't need u sub. Look, you can probably just look at it and figure it out.
How did you go from secant squared 2x to secant squared just u?
I set u equal to 2x. So, you know what I mean?
Yeah.
This is called u substitution. No, ask me, miss. It's all good.
I didn't see it.
All right. You okay, Espinosa? Because I see that. So you're not listening to anything, all right? Okay. Sorry, I'm not picking on you, miss. I just want you to get this calculus. Okay. Sorry. All right. Here we go, guys. So now we're looking at this cosine cubed x dx. I'm like, dang, I don't know what to do on this one. Break it up into stuff that we know. Everyone in here has had pre-cal, I know, because I was your pre-cal teacher. And I can break this up into cosine squared x times cosine x dx. Isn't cosine squared times cosine cubed? And I'll put this on the side. Valentine's is around the corner. We know that cosine squared x plus sine squared x is equal to 1. Yes or no? What I'm going to do, I'm going to move this. Let's see. What am I going to do? I'm going to move this sine squared to the right. And I'm going to write cosine squared x is equal to 1 minus sine squared x. Now, can someone tell me why I'm doing this? Almost. Watch. You see this? The reason, you see how I have a cosine x dx? I want to get a sine in there because if I make u equal to my sine x, my du will be a cosine x dx. Let me say that again. Guys. Focus. I want to get a sine in there. Lavelle, focus, miss. I want to get a sine in here because if u is equal to sine x, my du is equal to cosine x dx. Do we see that? All right, so here we go. I'm going to replace cosine squared with, put it in parentheses, 1 minus sine squared x cosine x dx. And now, no, well, see, that's why it takes practice makes progress. You need experience. This is why I tell you guys you need experience. Now, we already said, what did we say we were going to make u? Just sine x. Chav, how come last time we did the u, whatever it was on the inside? No, this time u is just sine x. Du cosine x dx. Side note again, just in case you just don't know. You do know because you've done this before. Sine squared x means this. Sine x with a square on the outside. That's all it means. All right, so here we go. Look at it works beautifully, guys. I don't see any errors. I think everything is perfect. The cosine x dx is nothing more than du, and I'm going to replace the sine x with a u. Integral, parenthesis, 1 minus u squared, close it, du. Look how beautiful that is. And it doesn't that look a lot simpler? A lot simpler. What's antiderivative of 1? Well, it's with respect to u. U minus what's antiderivative of u squared? And then because it has no limits, I put plus c. And then what am I doing with that u? I don't want it in terms of u. I want it in terms of... So I'm going to put what? Sine x minus sine cubed x over 3 plus c. You can also write 1/3 sine cubed x. It's the same thing. Plus c. That's it. Yep, that's your answer. Is this getting simpler, guys?
Bro, the first question I was like, what?
Okay. All right. If there's limits, so let's talk about if there's limits. If there's limits, you're not going back to your ex. I mean, you're never going back to your ex anyways in real life. But yeah, that's just asking for trouble, guys. There's a reason why you broke up with them, or vice versa. You know. All right. No, real talk. If there's limits, all you're doing is trying to get the expression to be simpler and equivalent. So there's no reason to go back to x's, just leave it in terms of u. But you're gonna have new limits, new everything. You're working on yourself, so you're working on your new self. So forget the x. Work on you. I like that. That's cool. Okay. All right. If there's limits, I don't know how I would write it down. If there's limits, you're working on u. Forget your x. You know what? Let's write that down.
What am I writing?
If there's limits, work on u, quote unquote, because that's like your u. Forget your x. Forget your x.
You should not write it down with just
All right. Here we go. Here we go. You guys ready? Check it out. We're going to go slow. Integral from 0 to the power of 3 of tan x secant squared x dx. You look at it and you're like, dang, that looks kind of tough. I don't know how to do it. You need to figure out a relationship. Is there a relationship between tan and secant squared? Yes, the derivative of tan is secant squared. And you recognize that. So immediately on the side, you're going to go, well, that means I can go u equals tan x. So that means du is going to be equal to secant squared x dx. Do you guys see that? All right, so I'm going to slow down. Here we go. I'm going to write integral. Notice I have not put my limits. Do not put those limits. We're going to put new ones. And I'm going to write, let's see, u is tan x and du. So I'm just going to write u du. There it is with sub. That is way simpler.
Wow.
See, u is tan x and secant squared x dx is du. Way simpler. Okay, here we go. You're not going back to your x. I need new limits. How do you get new limits? Plug in a 0 in here. What is tan of 0? 0. So there it is. So that came from tan of 0. Cool or not cool? Now, how do I get the upper limit? Plug in a power over 3 in here. Now, look, your pre-count never goes away, and it's not even heavy pre-count. So the top. So let's see. Tan of power over 3. In the unit circle, power over 3 is like at 60 degrees. Bam. And it's half, comma, square root of 3 over 2. It's a y divided by x. So square root of 3 over 2 divided by 1/2 is going to be, so square root of 3. And then how do we get that? We got that by just going tan of pi over 3. Cool or not cool? Okay. Guys, you do not have to go back to quote-unquote your x because this is the equivalent expression. This is the same as this one. So it's going to give me the same value numerically as the top one would. Does that make sense? Because look, I changed my limits. I'm working on myself. I'm working on you because it's a new u. Forget your x. We're getting this done now here. So here we go. Antiderivative of u. U squared over 2. Here are my limits. That's my line. So it just means evaluated at from 0 to square root of 3. And I'm going to put an equal sign. You can. As soon as you do that, that's correct. I'm doing upper minus lower. Square root of 3 squared over 2 minus 0 squared over 2. I guess that 0 squared doesn't do anything anyways. So all this square root of 3 squared is just 3. So my answer is 3 over 2. You do not go back to your x. I don't put a c because it's a definite integral. You don't put a c because it's a definite integral, guys. Are we okay? Okay, let's continue. So here we go. You look at it. So pretend you don't even know that this is U sub. Obviously, we know it's U sub, but let's say this is an AP exam or an exam, and you look at it and you're like, okay, I'm going to figure this out. How do I do it? You notice, what do you observe? I notice that the denominator has an x squared minus 4, and I notice that the numerator has 1 degree less than the denominator. So immediately you start thinking, maybe I can do U sub. If you do U sub, what do you make U?
In my mind, I would make it an x squared.
No, do the whole thing. X squared minus 4. Why? Because when I take the derivative of x squared minus 4, don't I get just a linear term? Yes, and I have a linear term in the numerator. So look, du equals 2x dx. Do you guys see that? Cool or not cool? I take my colored pencil so I can indicate what I'm going to add to it to make it a little different. I don't have a 2x dx in there in my integrand just yet, but I will. I'm going to put a what? a 2. And if I put a 2 there, what do I put on the outside? A half. I'm going to go back to my regular color here. 1/2 integral. I'm going to put new limits. So I'm not going to put that 0 just yet. And let's see. 2x dx is my du. And then the x squared minus 4 is my u. So I'm going to write it like this. 1 over u with a du on the side because it's easier for you guys. Cool or not cool? All right. Here we go. When x is 0, what is u? So put a -4. When x is 1, what is u? 1 squared is 1. 1 minus 4, -3. Are we still okay? Don't worry, guys. We're okay. All right. Here we go. I put the 1/2, and I write ln. And what's? Oh, dang it! You didn't see that. What's the antiderivative of 1 over u? ln, and I put absolute value of u. And I'm going to write -4 to -3. You're not going back to your x. If there's limits, you're going to stay with u. It's a new u. Cool or not cool? Here we go. Here's the 1/2. You can write the 1/2 on both of them, but I'm going to factor it out, guys. That way it's easy. So 1/2, and I'm just doing upper minus lower. ln, absolute value of -3, close, minus ln, absolute value of -4, close. Yes. Yes. 1/2 ln of 3 over 4. And if you want, you can move that 1/2 inside and call it square root of 3 over 2, but I'm going to leave it like that. And there it is. That's my answer. How do we feel? Okay. Don't worry, we don't have delta yet, but this is coming from delta. And relax, we're almost done, guys. No, just don't become a robot, because delta does a lot of... Okay, I'm not hating on delta, guys, because I love delta I love delta overall. But delta likes to solve for dx. And sometimes I don't like the fact how they have x's and u's, and then they cancel out the x's, and I'm not a fan of it. But if you think it's easier that way, then that's fine. All right, here we go. Let f be a function such that the integral from -18 to 9 of f of u du is equal to 3. What must be the value of integral from -6 to 3 of f of 3x dx? I don't know. All right, here we go. Here's how we're going to do it. I notice that there's a u right there, and I notice that there's a 3x right there. So I'm going to say, right, Lavelle, I'm going to say that u equals 3x. So now I'm going to write du equals 3 dx. Are we still okay? All right. So let's see. What am I going to do? I'm going to turn this guy, and I'm going to see if I turn it into a u, if I get this expression. So I'm going to do this. Integral from -6 to 3 of f of 3x dx. All right. So that's what they want. So what did I do? I said I turned that to, okay, so I'm going to write integral f of u. And I don't have that dx yet, so let me put, okay, I need a 3. So I'm going to put a 3 here. Oh, you know what? Let me put it next to this guy. 3 here. And then if I put a 3 there, I put what on the outside? 1/3. So then I'm going to put a 1/3 right here. So then now that 3 dx is just du. So there's my du. Now let's talk about my limits. So let's see. I had a -6, but that's in terms of x. If I plug it in here, what is 3 times -6? -18. OMG. What is 3 times 3? 9. Look at that. So hold on. So they want to know what this expression equals. So these are equivalent. That and that are equivalent. They're the same. Or what I'm trying to say is this, that this expression here is the same thing as this. -6 to 3. Actually, no, it's not the same. These are the same with the 1/3 in the front. So I have that 1/3, and well, I guess this is just the easy part. Sorry if I confused you. Everything that I have in a bracket, that's just what? 3. So I'll just have 1/3 times 3. And what's 1/3 times 3? 1. So this expression here is just nothing more than 1. There it is. That's what I wanted to say. Did I confuse anyone?
I
Okay, did I confuse you a little bit?
Well, a
Marcha?
little bit, not anymore.
Estrada? Yeah, it was my fault.
But then you fixed it.
Yeah, but I'm not satisfied with me, so I'm working on myself right here. All right, so, no, like, watch. Here's what I meant to say, guys. This expression and this expression are equal, but remember, it all came from this, and then this right here was given to me, this expression, so this is 1/3 times 3, and that equals 1, which is this guy. That's what that guy equals. Okay. All right, guys, I'm coming back in the evening in case I confused you guys. So hopefully the video sounds smoothly. What I was trying to tell you guys earlier, I don't know if it came across, is that this expression, the integral from -6 to 3 of f of 3x dx, is equivalent to 1/3 integral from -8 to 9 of f of u du. This is what we have, -6 to 3, f of 3x. I inserted a 3, I put a 1/3 on the outside. So then I have my little symbol here, -18 to 9. That -18 came from when x is -6. -6 times 3 is -18. And then the 9 came from 3 times 3 is 9. So then they have 1/3. And then this expression, this integral right here from -18 to 9 is just 3 because they give it to you. So 1/3 times 3 is equal to 1. This integrand here, -6 to 3 of f of 3 of x dx, is equal to 1. That's what I was trying to say. Maybe it made sense, but just in case, I'm making a little snippet here. All right, let's get back to the original. Cool or not cool? Okay.
That's another level I love. Oh my gosh.
All right. Here we go, guys. Last one, and then we'll give you guys practice problems. All right, here we go. What is my u going to be on this one?
I'm thinking 9 minus 5x cubed.
Why?
Because if you take the derivative, it will have an x squared.
That's right. If you take the derivative, guys, all it is, you're just looking for like how they're related. If it's a polynomial, well, it's not a polynomial because it's square root. But the 9 minus 5x cubed, when I take the derivative, I'm going to have an x squared. And you have an x squared on the outside. So 9 minus 5x cubed. So then your du is going to be equal to -15x squared dx. Do that. So before you do anything, here's what I'm going to do. You see that 3/2? I'm going to move it to the outside. Because I can do that, right? It's just a constant. So here we go. Yeah, I'm not writing limits yet. All right. Are you guys ready? Well, I mean, it's safe to write limits because this is in terms of x anyways. So you can write the limits. It's when you start writing in terms of u, right? All right. Here we go. Oh, yeah, that's a constant. Okay, just in case. Guys, just in case. Because remember, yeah, it's a constant, guys. It's just your constant properties. It's a constant. We can move it from the constant properties. Right, Gadetto? Okay. All right. Here we go, guys. Here we go. Focus. So I have a -15x squared. So this guy needs a what? So if I do that, then I've got to multiply this by a -1/15. So there it is. So let's see. Now I'm going to rewrite it. So here's what I have. Let's see. Doesn't 3 go into 15 5 times? So -1/10 integral. I'm going to put new limits. Now -15x squared dx is a du. Put the du at the end because the du signifies the end of your integrand. Square root of u du. The -15x squared dx is right there. And now doesn't that look a lot simpler? Okay, now I need new limits. When x is 0, u is 9. When x is 1, what's 9 minus 5? X is 4. Oh, look, they're making it nice for me. I'm going to use my properties again. You see that negative on the outside? Look at this. I have a 4 and a 9. Can I flip them and then remove the negative? So look, integral 4 to 9 of square root of u, and the 1/10 is still there. It didn't go away. With a du. Yeah, sorry, miss. All right, are we still cool? All right, here we go. 1/10. And I'm going to put this in a bracket here. What's the antiderivative of that? That's the same thing as u to the half, right? So I'm going to add 1 to the half. So u to the 3/2. And I'm dividing by 3/2, which is the same thing as multiplying by 2/3. And then I'm going to put a 4 down here and a 9 up there. Are we still okay? All right. So let's see. 2 goes into 10 5 times. And 5 times 3 is 15. So here's what I see. I see a 1/15. I'm going to put a bracket. I'm going to do upper minus lower. I'm going to put 9 to the 3/2, and we'll talk about that right now, minus 4 to the 3/2. Did I confuse anyone? Yeah, in case you're confused, look, 2 and 10, 2 goes into 10 5 times. 5 times 3 is 15. So I factored out the numbers. I put it in the very front. That way I don't have to have it on both terms, because they're going to be on both terms anyways. So I just factored it out, just simple algebra. Cool or not cool? All right, here we go. This can be simplified more. So 1/15 and then bracket the square root of 9. Here's what I'm doing first. You can do the cube root and then take the square root, the cube root. You can do a cube and then do the square root, or you can do the square root and then do the cube. Same thing with the 4. What's the square root of 9? 3. And 3 to the third? 3 times 3, 9. That times 3, 27. Minus, what's the square root of 4? 2. And 2 to the third? 8. And then finally, the last one, 27 minus 8? 19. So 19 over 15. Does that reduce? There it is. Done. So this expression in the very beginning just equals 19 over 15. Cool or not cool? All right, guys. So all we're doing now is practice. I got a handout for you. We don't have a delta, not yet at least.